Hello everyone, welcome to new class. Today's class is the continuation of Routh criterion, that is the problems related to stability analysis. So let us go through the problems. Construct Routh array and determine the stability of the system whose characteristic equation is s raised to 6 plus 2 s raised to 5 plus 8 s raised to 4 plus 12 s cube plus 20 s square plus 16s plus 16 equal to 0. Also determine the number of roots lying on right half of S plane, left half of S plane and on imaginary axis. So this is the question. So characteristic equation is given. So we have to construct the Routh array. So for that the highest power of S is S in the characteristic equation is 6. So the roots, number of roots are 6. Now we have to construct the Routh array. So for that the highest power of S we have to write here. So it is even order. So we have to write the coefficients of the even order S. So first one is 1, then 8, then 20, then 16. Next we have to write S raised to 5. So the coefficients are 2, then 12, then 16. So that's all. And here 2 is a common factor. So we can divide with 2. So s raised to 5 we can write again. So dividing by 2 we get 1, here 6, then 8. Now we have to construct s raised to 4 and s raised to 4 elements are obtained with the above 2 rows. So these 2 rows we have to consider, and here s raised to 4, the first element is 1 into 8 minus 1 into 6 divided by 1, that is 8 minus 6 is 2. Then next is 1 into 20 minus 1 into 8 divided by 1, that is 12. And next is 1 into 16 minus 0, that is 16 minus 0 divided by 1, that is 16. So here also we can divide by 2, that is s raised to 4 is again we can write as 1, then 6, 8. Next we can write s raised to 3. So the elements of s raised to 3 is obtained with the rows of s raised to 4 and s raised to 5, that is these 2 rows we can consider. And here 1 into 6 minus 1 into 6, that is 6 minus 6 is 0. Then next is 1 into 8 minus 1 into 8, that is again 0. So here s raised to 3 elements are 0. So that is the row with all 0 indicate the possibility of roots on imaginary axis. So there will be roots on imaginary axis. So we can conclude that the system is limitedly or marginally stable. And we have to write the auxiliary polynomial. So auxiliary polynomials obtained from the above row, that is from the elements of this row, that is s raised to 4. So auxiliary polynomial is a equal to, it is s raised to 4 So s raised to 4 is this one, s raised to 4 plus this is 6s square plus 6s square plus 8. So this is the auxiliary polynomial, that is the row with all zeros is the zeros indicate that there is imaginary roots on the imaginary axis, and the row above this all zero row is the auxiliary polynomial. So we get s raised to 4 then plus 6s square plus 8. And to find the elements of this row, that is s raised to 3 row, we have to differentiate this auxiliary polynomial with respect to s and find the coefficients of that differentiated polynomial, and that coefficient is equal to this row elements. That is, we have to differentiate this auxiliary polynomial, that is dA divided by dA by ds equal to, so we have to differentiate with respect to s. So we get s raised to 4 is 4s cube, then plus 6s square means 6 into 2, that is 12s, then plus 0. So this is 4s cube plus 12s. So this is s cube, 4s cube plus 12s. So here we can divide by 4. So we get s cube plus 3s. So the elements of s cube is 1 and 3. Now we can construct s square, and that is obtained with the above two rows, means s raised to 4 and s raised to 3. So 1 into 6, that is 6 minus 1 into 3 divided by 1, that is 3. Next is 1 into 8 minus 1 into 0, that is here we get 8. Next is s raised to 1, that is 3 into 3, 9 minus 8, 9 minus 8 is 1 by 3, that is 1 divided by 3. Next is 0. Next is s raised to 0, that is 1 by 3 into 8. So we get this 8 here. So this is the Routh array, and here the system is limitedly or marginally stable. So we can find the roots on imaginary axis from the auxiliary polynomial. So the auxiliary polynomial is a is equal to s raised to 4 plus 6s square plus 8, and let it is equal to 0. Here let s square equal to x implies we get x square plus 6x plus 8 equal to 0. And we can find the roots, that is roots of quadratic equation is equal to x equal to minus b plus or minus root of b square minus 4ac divided by 2a. That is, applying this equation we get here minus 6 plus or minus root of 6 square minus 4 into a into c, that is 8 divided by 2, and we get the roots are minus 2 or minus 4. That is, x is equal to minus 2 or minus 4, and x is s square, that is s square is equal to minus 2 or minus 4. From this we get s equal to plus or minus this root minus 2 and plus or minus this root minus 4. That is, plus or minus root minus 2 means we can write plus or minus j root 2, because minus root of minus 1 is j. So here we get plus or minus j root 4 is 2. So these 4 roots are lying on the imaginary axis. So we can conclude that the system is limitedly or marginally stable. And 4 roots are lying on imaginary axis. And while examining the first column of this Routh array, all the elements are positive. That is, there is no sign changes here. So, no roots are lying on the right half of S plane. So, the total number of roots are 6. Out of these 6 roots, 4 roots are lying on the imaginary axis, and the remaining 2 roots are lying on the left half of S plane. So, remaining 2 roots are lying on the left half of S plane, because in the Routh array there is no sign changes. So, no roots are lying on the right half of S plane. So, this is the conclusion of this problem. Let us do another problem. Construct Routh array and determine the stability of the system represented by the characteristic equation s raised to 5 plus s raised to 4 plus 2s cube plus 2s square plus 3s plus 5 equal to 0. Comment on the location of the roots of characteristic equation. So this is the characteristic equation given, and here the highest power of s is 5. So the number of roots equal to 5. Now we have to construct the Routh array. So highest power of s is s raised to 5, and the elements of odd powers of s are 1, then 2, then 3. Now s raised to 4 elements are 1, then 2, then 5. Now we can construct s cube, that is 1 into 2, that is 2 minus 2, 2 minus 2, 0. Next element is 1 into 3, 3 minus 5 divided by 5, that is minus 2. So here only the first element is 0. So we can replace this 0 with epsilon. Now construct the next row, that is s square, with this epsilon. So next element is epsilon into 2, that is 2 epsilon minus 1 into minus 2, that is plus 2 divided by this epsilon. So we can write 2 epsilon plus 2 divided by epsilon. Next is epsilon into 5 minus this, that is we get here 5. Next element is s raised to 1. So s raised to 1 is obtained, that is multiply these two minus these elements divided by this one, that is we can write minus 2 into 2 epsilon plus 2 divided by epsilon, then minus 5 epsilon divided by 2 epsilon plus 2 divided by epsilon. So here after simplifying we get minus 4 epsilon, then minus 4 minus 5 epsilon square, then divided by 2 epsilon plus 2. That is we can take this minus outside, then minus 5 epsilon square, then plus 4 epsilon plus 4 divided by 2 epsilon plus 2, and the next element is 0. Then s raised to 0 element is this one into this one, that is we get this 5 here. Now replace this epsilon with 0 again, that is construct the Routh array once again with replacing this epsilon to 0. So we get s raised to 5 as 1, 2, 3, s raised to 4 as 1, 2, 5, then s raised to 3. So to get s raised to 3, replace epsilon with 0, that is 0 minus 2. Then s raised to 2 is obtained. While putting this epsilon equal to 0, here we get 2 divided by 0, that is 2 divided by 0 is infinity, then 5. Then s raised to 1 is, here we get this minus 4 divided by 2, that is minus 2. Then s raised to 0 is 5. S raised to 0 is 5. Now we can examine the Routh array, that is while observing the first column, here there are two sign changes, that is from this is plus, then minus, then plus. So there are two sign changes. So the system is unstable because on observing the first column there is negative. So we can conclude that the system is unstable, and there are two sign changes. So two sign changes means two roots lying on right half of S plane, and the total number of roots are 5. So the remaining 3 roots are lying on the left half of S plane. So the system is unstable and 2 roots are lying on the right half of S plane because there are two sign changes, that is plus to minus and minus to plus, and 3 roots are lying on the left half of S plane. So that is about the problems with arrow full of 0 and only one arrow with only the first element is 0. That is about the limitedly or marginally stable system and unstable system. So in the next class, let us do a different problem. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.